Students, welcome to physics class. Today our topic is projectile motion. Projectile motion. Here a body which is projected at an angle theta other than 90 degrees with the horizontal is called as projectile. Let us suppose a ball is thrown. Let us suppose a ball is thrown with some initial velocity u. A ball is thrown with some initial velocity u, making an angle theta with the horizontal. Then this ball can be treated as projectile. Now we have to show that the path of a projectile is a parabola. Path of a projectile is a parabola. We have to show that the path of a projectile is a parabola. Let us suppose this x-axis represents the horizontal and y-axis represents the vertical. Here xy is called as a plane. Here xy is called as a plane. Here u is a vector called as velocity vector. In a plane, any vector can be resolved into two components. U is equal to ux I bar plus uy j bar. Here ux is called as the horizontal component. The horizontal component whose value is u cos theta, and uy is the vertical component. The vertical component whose value is u sin theta. Let us suppose this is the maximum height reached by the projectile. Then this is called as uy and this is called as ux. Let us suppose we have taken another point along the path of a projectile. At this point, the vertical component uy whose magnitude is decreased, whereas the horizontal component ux remains constant. In the same way, at this point, the horizontal component ux remains constant and the vertical component uy becomes 0. At this point, the horizontal component remains the same ux and the vertical components uy direction changes downwards. So along the path, the component ux remains constant. As the velocity component remains constant, along the x direction, we can say that along the x direction acceleration is equal to 0. That is, whenever the velocity remains constant, there will be no acceleration. And along the vertical direction, uy, that is u sin theta, varies, which is not equal to constant. U sin theta component varies, that is, there exists a change in the velocity, hence there exists an acceleration. This acceleration is equal to minus g, because along the vertical direction acceleration is equal to minus g, and if the body is moving towards the ground, acceleration a is equal to plus g. Now we have already depicted uy is the initial velocity, u is the initial velocity, and ux is the horizontal component whose value is u cos theta. Here theta is the angle made by the projectile with the horizontal, and uy is equal to u sin theta. And we have already know that along x-axis acceleration is equal to 0, because velocity component remains constant. Along the y direction, along the vertical plane, acceleration is equal to minus g, as there exists a change in the velocity along vertical direction. Now along x direction, that is along horizontal direction, from the expression s is equal to ut plus half at square, we can write s is equal to h, s is equal to x, the horizontal component, and u is equal to ux, and t is t, the time taken, and a is equal to 0 in the x direction, so the component half at square becomes 0. By replacing ux with u cos theta, we get u cos theta into t. By separating t, we get t is equal to x by u cos theta, which is the expression 1. In the same way, we can write the motion of projectile along y direction. Along the y direction, we have to derive the expression for the motion of projectile. For that, take again the equation of motion, s is equal to ut plus half at square. Here s can be replaced by y, because the motion is along the direction y. Y is equal to u is replaced by uy, and t is replaced by time of flight, or t is replaced by equation 1. Substitute t value from the equation 1, x divided by u cos theta, minus, because a is equal to minus g along the y direction, so minus half, a means minus g, so minus half g, t means from the expression 1, x by u cos theta. x by u cos theta whole square, because there exists t square term here. Therefore, by substituting uy is equal to u sin theta, we get u sin theta into x divided by u cos theta minus half g divided by u square cos square theta into x square. We have taken x square outside the bracket, outside this term. By cancelling u, we get sin theta by cos theta tan theta into x minus g divided by 2u square cos square theta into x square. The above expression y is equal to tan theta into x minus g by 2u square cos square theta into x square is similar to y is equal to ax plus bx square. Here a is equal to tan theta and b is equal to minus g divided by 2u square cos square theta. Here this expression we have derived, which is similar to the expression y is equal to ax plus or minus, we can say y is equal to ax plus or minus bx square. Then this equation is the equation of parabola. Here this expression is similar to the equation of parabola. So the path of a projectile, we can say that the path of a projectile is a parabola. That is, the path of a projectile, the projectile path looks like a parabola, parabolic path. This parabolic path is shown by the final expression y is equal to ax minus bx square. That is the parabolic equation y is equal to tan theta into x minus g by 2u square cos square theta into x square, which is similar to the parabolic equation. So we can finally conclude that the path of a projectile is a parabola. Thank you.